will be starting us off by discussing question 6 in topic 4. Specifically, we will discuss questions related to subtopic 4.3, which is power. Let's take a look at question 6a. Figure 5 shows a 15 kg block being pulled by a 100 Newton force at initial speed 2 meters per second up an inclined plane. The block travels a distance of 6.2 meters parallel to the inclined plane, which means it's traveling in the direction of the force up the inclined plane. The coefficient of kinetic friction is 0.14. The requirement of the question is, by using work energy theorem, calculate the change in kinetic energy of the block. And from the statement we have just read, we can gather all this information. So, we are required to calculate the change in kinetic energy, which is delta K. And the formula for delta K is final kinetic energy minus the initial kinetic energy. And there is also another component that uses the exact same formula, which is we can rewrite the equation like this. WorkNet also has another equation that we could use. We could use the free body diagram to help us. This is the free body diagram for this question, and as you can see, displacement is parallel to the x-axis, which means the forces that we are going to use is the force given, the kinetic frictional force, and also the Wx component. And thus, we can also write the equation as summation of Fx times displacement. And if you take a closer look, you can see that the cos theta is gone now. The reason for the absence of cos theta is because the angle between the Fx and the displacement is 0, and thus cos 0 is equals to 1. So we don't really have to write the 1 in the equation, and we could just leave it out. In the end, we can rewrite the equation as delta K equals to summation of Fx times displacement. The first step for us to tackle this question is to find the summation of Fx. To do so, we have to write down the equation of summation of Fx, which is equals to F minus kinetic friction minus Wx. To find the kinetic friction, we use the formula mu times normal force. And to those who are wondering how to find the normal force, we could use the summation of Fy to find the normal force. In this question, the summation of Fy is equals to 0, and thus the normal force plus the negative of Wy is equals to 0. If we were to rewrite that, we would get that N is equals to Wy. To find Wy, on the other hand, we will use the equation Wy equals to W cos theta, and the theta is equals to the angle of inclination. Wx is calculated with the formula W sine theta, and again the theta is equal to the angle of inclination. So in order to find the summation of Fx, we will use the equation that I have just stated on the previous slide, which is F minus Fk minus Wx. And since the F is already given, we will substitute the value directly into the equation. Next step is to find the kinetic frictional force, which is equals to mu times normal force. And in order to do that, we use the formula N is equals to Wy, and we can find the value of Wy component by using the formula for weight, which is equals to mass times gravitational acceleration. And from there on, we can substitute the value of weight into the formula W cos 25 to get the value of the normal force, which is 133.36 newtons. Next, we are trying to find the value of Wx by using the formula W sine theta. Just as we did previously, just substitute the value of W inside the equation and you can find the value of Wx, which is equals to 62.19 Newton. From there on, we just substitute all the values that we have found previously into the main equation, which is the equation of summation of fx, and start doing our calculation until we get the value of summation of fx, which is equals to 19.14 Newton. The next and final step is to find the value of delta k, which is equal to the summation of fx times displacement. By substituting the value of summation of fx and the value of displacement into the equation, we can find the value of delta k. To finally find the value of change in the kinetic energy, which is 118.67 joules.
And next for question B. The question is 120 kilogram motorcycles accelerate uniformly from rest to 25 meters per second in 5 seconds. Calculate the instantaneous power of the motorcycle at time t equals to 3 seconds. So as we want to imagine the motorcycle, how the motorcycle move is the motorcycle move from initial u is 0 meter per second to the final velocity which is 25 meter per second. So time taken for this movement is 5 seconds. So the formula that we will use for instantaneous power is P equal to Fv, where F is force and V is velocity at this specific time. So the first one is we need to find F. So as we know, F is equal to ma, and m that are given in the question is 120 kilogram. So and what we don't know is A. So we know from the previous chapter, A is equal to final velocity minus initial velocity over time. So we insert the information that we have, which the final velocity is 25 meter per second. The initial velocity is 0 meter per second, and the time taken is 5 seconds. So we will get the acceleration is 5 meter per second, and hence F will be equals 120 kilogram, which is our mass, times with A, which is the accelerator that we got is 5. So F that we got is 600 Newton. Okay, next we need to find V at specific time. Because at the question to find instantaneous power, we know instantaneous power is the power at specific time, and the question asks for time at 3 seconds. So we use to find V, we find so to find V we will use formula V equals to U plus AT. So U is initial velocity, which is 0, and A is our acceleration, which is 5, and T is our time, which is 3 seconds. So hence we will get final velocity is 15 meter per second. And we already got the two info that we needed to find P, which is force and velocity at 3 seconds. So we just insert all the information that we already find. So P equals to Fv, and P equals to 600 Newton times 15 meter per second. So hence we will get P equals to 9,000 watt, or 9.0 times 10 to the power of 3 watt. So that's all from us. Thank you.